Hello friends, welcome to DataPundit. So let's talk about DynamoDB schema design. So we have multiple videos of with respect to DynamoDB, but we particularly did not talk about how to create the schema, what needs to be taken care while deciding the key in DynamoDB table and schema in particular, which makes the schema of DynamoDB. So there are multiple concepts associated with this DynamoDB schema design. So, so whenever we create any DynamoDB table, we need to take care of keys, and then when we decide upon the key, so there are concept or there are considerations needs to be taken care while deciding the key, and so whenever any data comes into the DynamoDB for storage, so where the particular data goes, that also will be helping in data retrieval, right? So wherever it is going to be stored and how good in good way the data is stored, the depending upon that schema, the data retrieval happens. So how good way we store the data, the data retrieval will be depending upon that, right? So with respect to read capacity unit and all. So, so we know that what is DynamoDB. So if we talk about the background of it, so it's a NoSQL database. So like MongoDB. So somebody of you might have used the MongoDB. So that is the AWS service in particular equivalent to MongoDB is the DynamoDB. So it's a key value pair database basically. NoSQL database, if we call it as a, right. So it's a fully managed and serverless. So we don't have to provision an particular source, particular infrastructure for this. So in that way, it's easy to procure in management console and right and to use it. And let's talk about two or more attributes of it. So it's an inbuilt security, inbuilt continuous backup. We can do multi-region replication. We have a caching mechanism, in-memory caching. DynamoDB cluster accelerator we have, right, and the data import and export facility from and to the S3 bucket. So these kind of different attributes associated with the DynamoDB. So let's directly go into the schema part. So whenever we talk about an schema, so in traditionally like in a relational databases, right, we have a schema, right, a relational database schema. So we need to decide upon the what should be the different tables for a particular database, and again then what should be the key for what should be the different columns for that particular table, and again what should be the primary key, what should be the constant on top of it, what are the indexing part and all. So all those things we need to take care before we create the any particular database, particular tables, and in similar pattern or similar way we need to do here also in DynamoDB. So okay, so here also, so the main part of consideration while creating the DynamoDB table is the key part. So how or what needs to be considered while deciding the right key basically. So why we should take care about the right key. So if we randomly store the data in the DynamoDB table, that is not going to help. We choose the random primary key or random partition key or sort key or range key. So so that would not help with respect to data retrieval, and it may result into the throttling, and the data latency could be very poor in that respect. And also the storage, the scattered storage or could so that can result into the poor design, and that result into the poor performance of the all in all for the different access pattern. So the first part to be considered is the access pattern. We should know about the access pattern. Who are, how the different applications or different users are accessing the data. So that we should know, and that so the knowledge of that or the consideration of that would play a great role while designing the right key. And then the second part is throttling. So if we decide a different particular key, and if we don't take care about the data retrieval pattern and 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 uh, and other things like whenever we create the key, so where the data would be stored, right? So it should not be storing in such a way that throttling may occur, right? So what is the throttling? Throttling in the sense of so whenever we DynamoDB stores the data, right? So it when we create the table actually, so then there are read capacity unit and write capacity unit. So that if the people or if the applications or the users are having more, trying to access, the multiple people are accessing. Let's say we have 4,000 people are accessing, and the capacity is 200 people or 200 read capacity unit. So the throttling can occur, and the rest of the 200, uh, request can be denied, right? The capacity is less and the requests are coming more, so that may result into the throttling. So in simple words, and the data latency. So how soon or how quick the data retrieval happens, that is called data latency, So and the storage, and wherein all the data storage is happening, on how data is scattered among the partitions or stored within the different partitions. Okay, so that those are the different things we need to consider while deciding the right key. So this is the design creation part. So we will talk about in some time. So let's see if we have a data in such a way that, like, we have an account ID and we have another column as a date. Account IDs are like 1, 2, 3, and date are different dates. Okay. And if these kind of patterns we have, right? So so we have to decide the partition key for this and sort key. Okay. If so, this is one kind of use case, so one kind of consideration to decide and the primary key and sort key, right? So, so there are two types of key we have, primary key and sort key, partition key and sort key. Sorry. Okay, partition key is where the data, how the data is going to be stored in logical way, right? So depending upon the so whenever the any data comes for storage into the DynamoDB table, so there is a function called hash function, or there is a hash mechanism which will be applied to for the partition key, and the result, or depending upon the result of that hash function, the partition will be allocated for that particular record. So let's say if this kind of data is going to be stored, so if we have chosen the partition key as like account ID, so the first record may result into the partition number 1. Let's say we have two partition only and we have 3 records, right? So the second record may result into the partition number 2, and the third may possibly result into the partition number 1 again. So if this kind of data we have, then we what we would do is, because account ID is unique, and it is globally, data is unique inside the account ID column, so we don't have the repetitive data in the account ID column. Therefore we just chosen the uh, just partition key is sufficient while retrieving the data. Okay, so we, in this kind of scenarios, we don't need the range key, I mean the sort key. Okay, so data is going to be stored in this way, and we can choose the partition key as account ID. We may not choose the sort key. We may or may not choose the sort key, right? So because if we have to retrieve the data for account number ID 2, so we can give the search pattern as 2, and then data can be retrieved in easy way. Okay. Now there is a second second use case wherein we have a repetitive account id. So let's say we have two account id, two repetitive, so that account id itself is not a unique column actually. So in those cases we need to consider the sort key as well, or the range key as well, we call it as the range key. Or so in this first case the partition key is behave as a primary key. Okay, so account id is the primary key in this first case. And in the second case we have a, because it's not unique globally account id, so we need to consider any other key which makes as a composite as a unique globally within the table. So in this case we have to have the date as well. So the both the keys, right, account id and date would be as our primary key. So sometimes we call it as a composite primary key. Okay, partition key plus sort key becomes primary key in this case of. So whenever the data storage happens, like let's say we have two partitions for this for the storage perspective. So the hash, so whenever the first record comes, then hash mechanism is applied. Let's say it's going to the partition number 1, and then second record comes, then it goes to the partition number 2. Okay, a second again, the because account id 2, so the hashing will result into the same partition, right? So this will go into this partition number 2. So in these scenarios, the how this is how the logically the data would be residing in the physical locations. Okay, so partition number 1 and partition number 2. So let's say we have 400 total read capacity unit. Okay, as a whole, this is the upper limit for the particular DynamoDB table, let's say. Okay, when we create the DynamoDB table, we need to assign the RCU and WCU. So let's say we have 400. So by default, 200 the evenly capacity unit would be assigned among the partitions. So in this case, 200 RCU would be assigned into the partition number 1 and 200 into the 2. So 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 if the throttling happens, let's say there are a lot of people who are reading the partition number 2, who are want to retrieve the data for key as a 2. So if the throttling happens, right, for particular partition number 2 for this key as a account id 2, so what can be done? So in that case, uh, so in this case the throttling may occur because it's an hotkey, 2 as a hotkey in the sense of a lot of people are interested in this data basically. So a lot of requests are hitting this partition number 2. So if that is the case, if two more than 200 more than the two capacity is 200, even though we have 400 capacity, because it's allocated 200, so if the read requests are more than 200, the other requests are will be denied. Okay, we have a solution to, as a DynamoDB tables, as a DynamoDB property, we have the solutions for that. We will talk about that solution in later part of the video. So let's say in this kind of scenario we have like this, right? So let's take another example like department id and the opening date. Let's say we have this kind of scenarios. In this scenario we have a storage index on partition number, partition key, and the sort key would be as a range key as an why. Okay, let's talk about what is the meaning of the sort key basically. So whenever the data storage happens in this particular scenario, so the meaning of the sort, the indexing would happen on the partition key, right? Okay, the data, it will help in the data retrieval, and the sort key would be like if there is an, because it's a range key, right? So the descending and ascending part can be, the ordering would be decided that after the data retrieval, right? The ordering would be displayed on given in the result will be depending upon the sort key. So it will be, the data would be sorted depending upon the sort key, let's say. Okay, so like this, like this is a 2019 1st of October, 2nd October, like this. And this also, if within the same part key, that the data would be stored, ordered, okay, within the particular, for a particular key. Okay, okay. uh, so in the similar line we have like department and opening date kind of thing. So this is the partition would be, let's say, for partition number 1 and 3 record, and similar way. So this is the case when we have lookup of a non-global key. So we know that, the employee ID is behaving as a global unique key as a global. So the primary key or the partition key would be employee ID. So we don't need the joining date as a sort key. So use only the partition key in this kind of scenarios. Okay. And if we don't have the unique, need to use the partition key and sort key. Partition key as a department and sort key as a opening date, because we have a repetitive departments, right? So in these are the different scenarios basically, which would be taken which lead into the particular or important schema design basically. So that are the consideration when we uh, design the keys for a particular DynamoDB table. So let's talk about a few more concepts basically. So the throttling is very, very important concept with respect to the data retrieval actually. So if there are a lot of people who are trying to access the particular DynamoDB table record, and it is more than the read capacity unit for a particular DynamoDB or a particular DynamoDB partition, then the throttling may occur, right? So the excessive retrieval request can be denied. So uh, so what are the different what are the reasons when the throttling happens basically? So when burst in read operations happens, a lot of people are accessing the same accessing the trying to access the DynamoDB table. This may result into the particular hotspot, and also there is a hotkey case. Okay, so there is a lot of requests are coming in for a particular partition or particular data actually. Okay, and uneven data distribution. So let's say we have a 10 keys or 10 partitions, and we have 1,000 records, and we have 600 record in one partition, and rest of the 400 records are equally in the 9 partitions, right? So lot of requests are coming in for a particular partition number one. So if that kind data distribution is uneven among the partitions, then throttling may occur, right? For the lot of requests can come and go. I mean, would hit the partition number one, and because our read capacity unit would be equally distributed by the DynamoDB table. So the read capacity unit will be distributed evenly, but the requests coming in from the users or applications are uneven. A lot of requests are coming in for a particular, so therefore it can result into the throttling, and the wrong partition key and sort key. So they in turn will result into the kind of uneven distribution basically. So we need to take care of the data distribution when deciding the particular partition key and all. So what are the different things we can think of, or what are the different ways so that we can prevent the throttling basically? So there are ways. First of all, we can use the prefixes and suffixes. So if while deciding the partition key or sort key, if nothing is working out, so we can use the necessary prefixes or suffixes, so that we can make the data unique, and we can create the absolute I mean partitions, so that the data can be distributed evenly. In this case, composite partition key also will help. So if or a particular key, let's say account ID is not sufficient, account ID plus the date is not sufficient to uniquely identify the record, so we can add up multiple other columns so that uniquely can distribute, and then in altogether the goal is to distribute the data in among the different partition evenly, so that that throttling can be prevented, right? Also, and the DynamoDB accelerator. So if the for the lazy people, so if they don't want to work upon these kind of things, I mean in this kind of things, they can use the DynamoDB cluster. So that is the caching mechanism supplied by the DynamoDB. So it is a caching, because it's caching comes with the because caching will be depending on, there will be a EC2 instance associated with caching. So there will be a EC2 nodes actually. So there is a cost associated with the DynamoDB cluster accelerator, actually DAX. So if you don't want to do anything of this kind, then DEX can help to prevent the throttling in multiple occasions, right? And the fourth part is local secondary indexes and global secondary indexes. These are the two more concepts which are in depth we are going to see in next couple of videos, particularly local secondary indexes and global secondary indexes. Okay. And then there are concepts adaptive capacity. So I was talking about these things, right? So what if we have more than let's say multiple people are accessing this partition, okay, partition number 2, that meaning the account ID 2 is the hot. A lot of people are interested in this. So, and our requests are going beyond the 200 capacity unit. So there are chances of happening throttling. So to prevent the throttling, in this case, the DynamoDB comes with the adaptive capacity, meaning this partition number 2 can borrow the capacity from the other partition. Let's say from the partition number 1. So it can say that give me some capacity. So it can borrow up to 200 more, right? Because that is the capacity of this partition number 1. So in total, in worst case, it can borrow everything and it can make as a 400, right? So because in total we have 400, so it cannot go beyond the 400. So the within the 400, if it can prevent the throttling, it will be preventing. If the read if the read requests are going beyond 400, then throttling cannot be prevented. But from 200 to other, to up till the maximum capacity of the total table, the throttling can be prevented. So that is called adaptive capacity. So this is an important concept which were introduced in middle of 2019. Okay, earlier it was not there. So so that is this one is concept actually. So that can also adaptive capacity is the can prevent the throttling. So you can read more about the adaptive capacity. This is the link for it. So what happens in adaptive capacity is boost throughput capacity to high traffic partitions. So if there is a high traffic partitions, it can boost the capacity to while borrowing the capacity from the other partitions. Second is isolate frequently accessed items. So it can access. So what it can do is it can isolate the frequently accessed items. So it can divide the frequently accessed item to different partitions, okay, so that throttling may not occur. Okay, so for partition number 2, it can generate multiple other partitions. So there is an inbuilt it happens automatically, magical way. Okay, we don't have to do anything for with respect to adaptive capacity. So but as a concept, it is this. Okay, and there is another link for choosing the right partition key, so you can explore this as well. So this is all about DynamoDB schema design. So thank you so much.